right, so we're going to start looking at exponential functions. In these first couple of lessons, we're going to look at basically comparing the linear, quadratic, and exponential functions all together. So some of it will be review, and then some of it with the exponential functions will be new stuff. So let's take a look here. So obviously, the very first graph that I hear that you see on the very far left, this is going to be a linear function, okay? And so the reason why I know it is linear because it makes a line. So linear functions are going to make a line. And so we have, remember, so for this, you're going to have an x-intercept. This is also where y is equal to 0. You'll have a y-intercept. That's where it crosses the y-axis, where x is equal to 0. And then don't forget that we have rise over run as slope here, or rate of change. And then that would be the slope of my line. So that's measuring that steepness there, okay? And then for the second, the middle function or graph we have quadratic. So this is a quadratic function. The shape of this makes a parabola, or some you like to say parabola, whatever. So just a couple of key attributes there. Remember, I'm going to have that very top or bottom point as a vertex. Normally, we refer to that as a maximum or a minimum. Then you have a axis of symmetry that goes straight down the middle. And then you're going to also have a y-intercept every single time you'll have those things as well. Not always, but usually you will have the x-intercepts. And remember, there are usually going to be two of them. There could be one of them or there could be none, okay? So all of those are possible as well. But every quadratic will have a vertex, will have an axis symmetry, and will have a y-intercept. And then the last one here you'll see is what we have as an exponential. And here, there's a couple of key attributes I want to pay close attention to. Yes, it does have a y-intercept, okay? It will always have a y-intercept. It will always cross the y-axis, but it may not always cross the x-axis. So it may not always have an x-intercept. But do you see this gray line that's kind of over the x-axis there? I'm trying to look and see. So that is going to be what's called an asymptote. So asymptote, asymptote. So an asymptote is a vertical or horizontal. In this instance, for exponential functions, it will only be horizontal. Okay, and it's an asymptote where this is a line, horizontal line, that a function gets really close to but doesn't ever cross. Okay, so if I were to shift my exponential function up or down, so on the y-axis, then you would see my asymptote move up or down. Okay, so it's just a horizontal line that the exponential function is going to get really close to. But never cross. It's never going to cross that asymptote. And so for this instance, this would be the x-axis. So for here, we'd have no x-intercept. It would get really, 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 really close to the x-axis, but never get there. Like 0.00000001, get really close, never touch, okay? And part of that is because I'm taking half of something, and if you take half of something, you'll never get there. Now, to the eye, it may look like you're there, okay? If I were to get half as close to the computer right now, and then half again, and then half again, by physical space, I would have to touch the computer. But technically, when you start getting down to the very, very centimeter or millimeter, I would never touch it. That's the whole point of it. All right, so we're going to look at domain and range, and we're going to review those for linear functions and quadratic functions, and look at those for the exponential functions. So for my linear function here, you'll see that I have just a sectioned off piece. So I have a piece here. This looks to be at like -4, -3, and then all the way over here at 8, 0. Okay, so remember x comes first, then y. Remember, go right or left, then up or down. So the domain, I'm going to start with my very farthest left, which is -4. And the very farthest right is 8. Now, next to -4 is a filled in dot. So remember, that's going to be equal to. So a filled in dot or a line at that point is going to be equal to. That means it's going to include -4. Negative at 8 here, it's not going to include that. And then the range, remember, I like to start at the very bottom. So I'm going to start at -3. So that's my very bottom of my function there. And then that is going to go up to the top, which is 0. Since -3 is where it has the filled in dot there, I'm going to have equal to there. So remember, domain is the value, is the x, is a set of x values, and then range is a set of y values. Let's look at the middle function there. We have a quadratic as well again, and we're going to look at that, and it's just sectioned off as well. So we're looking for the domain. So I'm going to go from the very farthest left, which looks to be right here at -3. Right there, that's the very farthest left, all the way to the very farthest right, which is right here at +3. And since the -3 is not filled in, we're going to leave that just less than, and then since the 3 is filled in, it's going to be equal to there. And then the range is going to be the very bottom, which is down here at -5. I'll write that with a different color. It's actually at both of those are at -5, all the way up here to 4. That's the bottom. Here's the top. So I go from -5 is less than y is less than 4. Okay. Now, since up at the top 4 is a line, it's going to be considered to be a filled in dot. Line is just infinite amount of dots all filled in. And then at the bottom, you'll notice that one dot is open and one dot is closed. So since this dot would overpower that one, it's going to be equal to as well. That one's kind of tricky there. All right, so let's look at now exponential functions and how this looks for domain and range. So for the domain, and this is not a sectioned off piece, this is the entire piece of an exponential function, and it looks like it's going to be stopping about 2 and maybe not ever get very wide. Well, it will get wider. Okay, and so the domain will be all real numbers. So I like to write that with the double R, or you can say all real numbers. So just like with our quadratic function, the domain, the whole part of a quadratic function, the domain was all real numbers unless you had a sectioned off piece. And then the range is what was restricted. Again, same thing here. So for the range here, the very bottom is down here at 0. So y, and it's going to keep going up, 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 up. So y is going to be greater than 0. It's not going to ever be 0 because remember, that's that asymptote there. Okay, and you can't ever get there. So it won't ever be 0. It will always be greater than 0. It will never be 0. Okay, so that's the restriction there. All right, so let's look at the bottom left graph there. And so we have a restriction, another sectioned off piece. So I'm going to look at the domain. Remember, I need to start from the very farthest left. So that's going to be here at 0. And domain is a set of x's all the way to the right, which is here at 7. And since they're both filled in dots, they're both going to be equal to here. So that's the domain. And then the range, I'll start at the very bottom, which is going to be at 0 as well. And then go all the way to the top, which is 420. And both of those are equal to because they are both filled in. All right, so for the bottom middle function, we have a sectioned off piece of a quadratic. And so for domain, I'm going to start at the very farthest left, which is right here at 0. And go all the way to, I'm going to guesstimate there. I'm going to say like 0.8. We'll just guess, okay? Since there's not an actual point right there and it's not telling us. So since those are both filled in, those are both going to be equal to. And then for the range, the very bottom is right here. So don't let this number right here trick you, like, hey, I'm starting down at the bottom or at the very beginning of it. You're looking at the very bottom of the function, which is at 0. And since it's filled in, it's going to be equal to. I'm going to go all the way up here to the top here. So maybe at 4.5. And since it's a line, or I say a line, it's a curve, and it's filled in, it's going to be equal to as well. So 4.5, I'm guesstimating there as well. Don't worry, you don't have any of those where you have to guesstimate on your skill check. All right, so for here, we are going to have this one starts right here up here at 10. So there's a filled in dot up there. It's kind of hard to see, but it is filled in. So the domain is going to be all numbers that are greater than or equal to this very first number, which is 0. So this is an arrow that keeps going on and on and on farther to the right. And then the range is going to be restricted as well. It's actually going to be the very bottom. It's never going to reach 0 again. It's that horizontal asymptote. So 0 is less than y because it's never going to be equal to 0. Y is never going to be equal to 0. And then less than or equal to positive 10, since that's a filled in dot, it's going to stop there. Again, you won't have some questions like this where it looks kind of confusing as far as like, hey, what number is that? Is it a dot? Is it a line? Or is it an arrow? That kind of thing. But I just wanted you to get a good feel for domain and range. So on your skill check, you're going to be responsible for x-intercepts, y-intercepts. You're also going to be responsible for domain and range, for linear, quadratic, and exponential functions. And so this is just a little piece of it. Also, you are going to be responsible for the asymptotes for the exponential functions. So just make sure that you are pretty clear on that. Remember that I host a Schoology chat every day at 3 o'clock. So if you're working on this and it's like noon, you send me a message and I get back to you and you're still not sure, then hop on at 3 o'clock and we can kind of chat real quick and see, hopefully they'll clear it up, and then try skill check again. All right, and so that's it. We're just kind of baby stepping in for exponential functions.